My name is Remco Timmermans and I will take you live into the action during these live stream intermezzos. I will talk with the people who make this event the biggest space and robotics event in Europe. This morning I'll be talking to Dr. Anna Łosiak, the chief scientist at ERC, if I may say so, and the designer of the Mars Yard. So Anja, every year the ERC Mars Yard is redesigned, reflecting different areas on Mars and different features. Can you take us through the design of the 2021 edition and the scientific ideas behind it?
Of course, yes. As you mentioned, every year we are trying to have some new tricks and new ideas to show our teams and our people that visit our competition. This year we are going to visit, virtually visit Elysium on Mars. Elysium is a very interesting location because it's a place where volcanoes are meeting ice. So very interesting from the geological and also potentially astrobiological point of view. But this area was selected for this particular year, 2021, not by chance. We have selected the region of Elysium because there were a couple of publications released this year that were pointing to possibility of still having active volcanoes on Mars surface. The first publication was released in the beginning of this year, and this was actually the reason why we set it up on this team, because the design of Mars Yard takes a long time. It really starts very shortly after the previous edition of ERC is done. So the paper that I'm referring to suggested that in the section of Elysium there can be geologically active volcanoes. And it was based by kind of standard planetary geology method, some mapping of the area, how fresh it looks, crater counting, all that stuff. And additionally, a lot of people were not believing this paper because this is kind of shocking suggestion to make. However, only 2 months ago, data from InSight was released, and this data actually suggests that not only the inside of Mars may be still hot, so may still produce some magma, but also around the same location that was suggested in this previous paper, there are a lot of Marsquakes. Marsquakes that may suggest that lava is moving there, exactly at the same spot. So I would like to say that we are very up to date with the current state of geological research on Mars, and also quite exciting because our volcanoes are also erupting.
Excellent. Well, thank you. That was a very good introduction. Now, not only does the Mars Yard reflect the latest in science on Mars, it should also offer interesting challenges to the teams that we see behind us here. What are the key challenges built into the Mars Yard to challenge the teams? Yeah,
so actually the first thing is that it's challenge to prepare that to be challenging enough for some of the teams and easy enough for others, so that everyone can participate, even though maybe something broke down and they are not able to participate on their full capacity, or the team is just starting, so they need also some easy parts to travel through, and also very complicated and tricky parts. For example, some of the most evil parts that we have designed this year are not only the impact craters that are pretty deep, and some of the rovers may, once they go down, they may never go up. But we also have a very sneaky lava caves. Down there, if they are not driving carefully, if they are not paying attention to their surroundings, that may be their last movement on this Mars Yard.
So plenty of places for the rovers to get stuck, and right behind us we see this one escape one of the craters. So far so good for
that's a very easy crater, very old, a very eroded crater. Okay. The other ones are not like that. Again, we have different levels of complication for different teams.
Right. Looking at the images from Mars, we see a cold, seemingly endless, dead desert. Yet scientists, much like yourself, look at the Moon and Mars for clues about the origin of our solar system. What can we find on the Moon and Mars that we cannot find on Earth? I mean, Earth has rocks and deserts too.
Yes, we do, but those are different rocks and deserts. Some are quite similar, some are others, but for example, only by going to the Moon and to Mars, we can learn a lot about the very, very early Earth. And it's a very important question because we really don't have much information about how our own planet looked like when the life was being formed here. We do not understand the situation, and this is caused by the fact that we have very, very active geological processes happening on our planet. We have plate tectonics that are constantly crushing, remelting, recycling rocks, which means that all the information that we had, all the rocks that were formed this 4 billion years ago are just gone. There are only like really, really resistant pieces of minerals that are left over that survived all this time, but they are very limited in what they can say about Earth. However, on other planetary bodies, like on the Moon, like on Mars, geology is less enthusiastic, less active, which means that all those interesting rocks from the beginning of solar system have survived. So we are going to Mars and Moon not only to learn about those other bodies, but also to learn about our own planet, to figure out how life was formed and why we are here.
Okay. Thank you very much. Now, you said this Mars Yard is designed specifically for this year's competition based on papers that you read early on in this year.
Not only me, I would like to clarify that I'm not the only person that works on all of that. I would never be able to do that alone without my amazing team. We are really 6 to 8 people working for a year to make sure that this looks and works as it does.
Fantastic. Yeah, of course, this whole event is teamwork.
Yes.
You know, it's all people who are doing the work. So a very good point that you're making here. But have you read anything after doing the work here that has already inspired you for maybe subsequent editions?
Oh, I'm not spilling the tea. No. That will be the thing to think about after we are done with this edition. Maybe I have some ideas. I'm not saying no, but we cannot exclude that there will be a paper that will show up that will be saying something extremely interesting, and we will decide to replicate that in our current Mars Yard or next year, I mean, as we did that for this Mars Yard here.
Right.
We were not imagining that we will have active volcanoes on Mars Yard.
Fair enough. Let me ask you the same question the other way around. What are the key lessons learned from previous editions that are now built in here?
Oh, that's a very interesting question. Well, I think that the important thing is to make sure that all of the features that we see here some of the features are clearly interacting geologically and others are not so clear. Because what the scientific task is all about actually is not only, just drive around the Mars Yard. It's not a pile of rocks randomly distributed. No, there is a geological story that is within this piece of environment that the teams are supposed to figure out based on the remote sensing data, aka drone data, that they get before the mission. They analyze the data and they prepare a geological map. Based on that, they figure out how to where to go to, where to analyze everything, and during the mission they have to execute their own plan. So the main important thing is to not to make it too easy and not to make it too hard,
Right.
because some teams will not be able
Right,
to
that makes
figure it
perfect
out.
sense. Okay, well, thank you very much for this introduction,
Thank
Anya. Please keep watching the live stream. We have a lot more coming on. Follow us on social media. We are on Twitter, on Facebook, on LinkedIn,
And
on
come
Instagram.
to Kielce.
And of
next
course,
year.
if you can, today it's a beautiful day. We're continuing tomorrow. Come to Kielce.
This year
and-
or next year, wherever we will have the ERC.
Of course. So thank you very much.